Hello everyone, I hope that you understood my last lecture, that is capacitance of earth and the principle of capacitor, and as well as one most important topic we have done, that is capacitance of a parallel plate capacitor. Capacitance of parallel plate capacitor, when the space between the plates of capacitor is empty, means we have not kept anything between the plates. Okay, so let us see what we have done earlier, means last topic. So if you can see on your screen that we have done this topic, capacitance of parallel plate capacitor, you can see the space between two plates is empty, means nothing is there, it's a vacuum. Okay, and then we have calculated that when vacuum is there between two plates of capacitor, then capacitance will be epsilon naught A upon D. Just see on the top of your screen, it is epsilon naught A upon D when the space is empty between the plates. And now our next two topics are very important, that capacitance of parallel plate capacitor when dielectric slab is there between the plates, and last when conducting slab would be there. Okay, so let us start first when dielectric slab is there. So I am showing you diagram on my book. So these are the two plates P and Q they have taken. Here now we have drawn only single line. This is your choice, you can draw plates also, but if single line you will draw, diagram is diagram. In diagram we just have to show. So these are the two plates of capacitor P and Q. Okay, and distance between these two plates means what is the distance between two plates, that is small d. Okay, and one dielectric slab we have placed in between of these plates, and what is the thickness of this dielectric slab, small t. Okay, and we have applied one electric field, we call it E0 applied electric field. Okay, and you know then when you have applied electric field and we are keeping dielectric in between, so one more electric field would be there, EP, and that name we have given electric field due to polarization. Electric field due to polarization. Positive charge is on this plate, negative charge will get induced on this plate. If positive charge is on this plate, so obviously on that side of dielectric here it will be negative charge, because we know that positive and negative attract each other. Positive and negative attracts each other. Okay, so in this way you have to draw signs, means charges. So this is all about diagram, and now let us see your theory and mathematical calculations. So capacitance of parallel plate capacitor having vacuum or air between the plates. Just now I told, means the last topic we did, that when there is a vacuum between the plates, then capacitance is epsilon naught A upon D, and A is the area of each plate, D is the distance of separation between two, and everything else whatever I told that you have to write here. Okay, now we'll write potential, that what is the potential difference between two plates. So potential difference is always equal to electric field into distance. Now how electric field into distance? Because you know that E is equal to dV upon dx. Electric field is negative gradient of potential, means electric field is equal to potential upon distance. So potential will be electric field multiplied by the distance. That's why here potential is equal to electric field multiply distance plus electric field multiply distance. Now how this d minus t and dt? So let us understand from here, electric field in this area is E0, but more than half of the area is covered by the dielectric. Total space is D, and dielectric has covered the space T. So how much space left now for E0? पहले E0 के लिए ये पूरा स्पेस था, ओके, मीन्स D स्पेस, बट जब डाइलेक्ट्रिक जिसकी थिकनेस जो है वो T है, उसको बीच में रख दिया, तो आपके पास कितना स्पेस बच रहा है E0 के लिए, दैट इज D माइनस टी. सो दैट्स वाई E0 मल्टीप्लाइड बाय D माइनस टी प्लस inside the electric field is EP, or simply you can write it E, and what is the distance for this space, that is T. So ET. Once again, V is equal to electric field multiplied D minus T plus electric field multiplied by a T. Okay, now in our last topic we have studied that E naught upon E, applied electric field to the reduced value of electric field is equal to K. Okay, E naught upon E is equal to K. To calculate the value of E from here, E is equal to E naught upon K. So go back again, V is equal to E naught D minus T plus E naught upon K. In place of E, what we have kept? E naught upon K T. E naught and E naught you can take common. What left inside? D minus T plus T upon K. So this equation you can give equation number 2. Okay. So now once again E naught, we know that it is sigma upon epsilon naught. And what is sigma? Charge per unit area. These points you must keep in mind that electric field is sigma upon epsilon naught and sigma is charge upon area. Again and again we are using these. So Q upon A epsilon naught. So E naught value is this. Put this back in equation number 2. So V is equal to Q upon A epsilon naught D minus T plus T upon K. This is the value of V. But we don't have to calculate V. Our objective is to calculate C. And what is the C? C is equal to Q upon V. Okay. So Q means Q. V value is here. Put it back. A epsilon naught is in denominator. It will go up. Q and Q will cancel out. So it is epsilon naught A upon D minus T plus T upon K. So after this you can see that A epsilon naught D they have taken common, 1 minus 1 upon D plus 1 upon dk. These are the simple calculations. Go through these and then you have to divide C by C naught just to compare. Okay. So C upon C naught we are dividing. When you will divide it, the terms will cancel and at last you will left with this relation. Okay. I'll do it on. You can check here that we have written that C is equal to epsilon naught A upon D minus T plus T upon K. This is the value of C. So no need to solve after this. You can keep up to here also. Okay. So this is T upon K. What is the value of C naught? C naught was equal to epsilon naught A upon D. This was given equation number 1. This is equation number 1 and this we got capacitance when dielectric slab is placed between the plates of the capacitor. Now if T is equal to D, if T is equal to D means thickness is equal to distance. Here you have written if dielectric slab wholly fills the space. Wholly means it is totally fit between the space. No space left means T is equal to D. So you can see here that I have written if T equal to D. So put T is equal to D here. So C will be equal to epsilon naught A upon D minus D plus D upon K. D minus D equal to 0. So C is equal to epsilon naught A upon D upon K. That K I will take. So K, and what is epsilon naught A upon D? It is C naught, means when the space is empty. So C is equal to K times C naught, and simply we can say that C is greater than C naught. That means the capacitance when dielectric slab is there between plates is greater than the capacitance when vacuum is there. Means when you are placing dielectric slab between the plates of the capacitor, then its capacitance will increase. Okay, so this is all about your the capacitance of capacitor when dielectric slab fills the space, and next is your capacitance of parallel plate capacitor when conducting slab fills the space. So it is also very easy. same as this only one difference is there, that inside the conductor electric field is 0. I told you earlier also that charges in a conductor resides on the surface only, and inside the conductor the electric field is 0. Okay, so everything will remain same, but in place of E there will be equal to 0. Okay, so go through this concept, and if any problem you will face, you can ask. I'm dictating it from book only, so you can see that these lines are same, that when vacuum is there, so C naught epsilon naught A upon D, A is the area of each plate, everything is there, but inside you can see E is equal to 0. E is equal to 0 in conducting slab, E equal to 0. So here V is equal to E naught D minus T, only one value will be there, there will be no E into T because E is 0. E naught sigma upon epsilon naught D minus T, and sigma is charge per unit area Q upon A. Okay, then C will be Q upon V. So put the value of V from up. Okay, and then you can solve it when T is equal to D, and you will get at last your desired result, that if T is equal to D, then C is equal to epsilon naught A upon 0, C is equal to infinity. So see the interesting result, that capacitance will become infinite if conducting slab is placed between the plates of the capacitor. So these two topics are very important from examination point of view. So dear students, go through these topics, and if you are facing any problem, you can ask anytime. Okay, so thank you, good day.